All right, let me see. I think everything's working. Hopefully you guys can hear me okay. I changed some things with my mic. Sorry I'm late. My hair and makeup guy just took forever. So, pre-production stuff, you know how it goes. That light's obnoxiously bright, but we're going to leave it. That's fine. Okay, looks like we got about 28, 29 people here. That's pretty cool. So, all right, welcome to the live stream review. So we're going to talk about Cycle 7 test and what's going to be on it. And we'll be talking about, let me see, evaluating expressions. And then we'll be talking about, some of you guys have hilarious pictures. Anyway, evaluating expressions, distributive property, combining like terms, and I think that's it. Maybe talking about equivalent expressions. There might be one or two problems that we'll do. We'll see how our timing is. I have till about 9 o'clock tonight, so I'm probably going to wrap up around that time. I know last time I went a little later at some people's request, but I think this test, I feel like we got a pretty good handle on this one. So feeling pretty good about it. You guys should feel good about it too. A lot of good stuff happening in class. I feel like there's been a lot of good discussions. I feel like the technology has really been helping us. So I'm feeling optimistic, and I think you guys should too. But again, everything is, you get out what you put in. So being here tonight is step one of getting some extra help if you need it. I know that some people are maybe viewing this the next day, so checking this out the next day if you couldn't watch it live, that's also a good decision. Make sure you're doing a note card for your test. So that being said, if we're working on it here, probably going to be on the test, and obviously we'll be on the test, but also probably a good idea to put on a note card too. So again, that's all good test preparation. So by trying this stuff now and putting on a note card, kind of prepping your brain, that gives you a lot of time to get ready before Thursday. So we'll do a review game tomorrow as well. So we got a lot of good stuff going on. So this one, feel good about this one. You guys know more than you think you do. I think that sometimes we get kind of hung up in a lack of confidence, when realistically it's not that you don't have the ability. It's just you're kind of doubting your ability. And I see a lot of times on tests, I see the right answer erased, and then I see a different answer over the top, which is also erased, and another one. So I see a lot of people kind of second guessing themselves. So take your time. Again, the more practice you do, the more confident you are that you're doing it correctly. So again, tonight's review will help with that as well. So, all right, let me get started. Last time I used this green marker. I just want to check really quick, but now that my lighting's a little better. Nah, it still doesn't show up the way I want it to. Let me try the blue. Yeah, I think the blue is going to be the way to go, so I'm going to stick with that. So let's get started. And I've actually got two computers going here, and so three monitors really. I have my school computer, I have a TV I use as a monitor, and then I have another monitor here. So I got a lot of things going. So if you see me looking at all these directions, I promise I'm not as confused as I may seem. So man, we've topped our record. We got 38 viewers. It's pretty cool. Good. I'm glad this is working out for you guys. All right, so I'm going to use another set of word problems. And this word problem says that there are 8 gallons of Gatorade in a container. And I just realized you can't see this, so I'm going to type this into the comment section here. So give me a second. I'm going to put the problem in there. Let me see. I'm a college educated man. I should be able to figure this out, right? Okay, hold on. I got a plan. That plan might not be going as smoothly as I'd hoped. Hold on. Share. Okay, so I want to go. Okay. All right, here we go. Let me see. All the links I need are on one computer, and my stream is on the other computer. So I've got my stream is on the other. Oh, that's awkward. And I hear myself there, so that's creeping me out. Okay, there we go. All right, so now in theory, I should be able to comment. Okay, perfect. All right. So here is what the problem says. So you guys watching, you'll see this in the comment section in a moment. Okay, there we go. Here it comes. So here's the problem we're looking at. Okay, it's in the comment section. And I will put the 2 pieces that you're being asked to do for the, if this were on a test, this is what you would have to do. Okay, hold on. So here comes A and B. If it looks a little funky in there, I apologize. Okay, never mind, it worked out. There's 2 pieces to that question, but that's what I'm going to be looking at. And then it's asking you for 4 cups and 10 cups. So 4 cups and 10 cups. So that's 2 separate problems. Okay, so now you have all the information. And oh yeah, the feedback should be gone now. Let me know if it's. Oh, maybe it's not. No, it should be. Okay, well, whatever. That should be good now. I think, yeah, there was feedback because I had my computer looping, so my bad. All right, that should be gone now. If it's not, please let me know and I'll make some adjustments. So, all right. So again, the problem says, as you can see in the comments there, it says there are 8 gallons of Gatorade in a container, and Sylvia fills cups with half a gallon of Gatorade from the container. Okay, and I know it says lemonade later, but it shouldn't. Okay, so we got 8 gallons of Gatorade. Okay, so I'm gonna, and again, I always recommend bring a highlighter with you to the test. I think it's always great to highlight the numbers in the problem along with their labels, but then I also like to highlight the question. And so I usually highlight the question last, and I kind of read that question and I think to myself, okay, what am I being asked to do? And then I go back and I highlight the numbers as I see them. Okay, and then I think about that question again. What am I being asked to do? And then how do those numbers relate to that? And then I go back and I read that question a third time, and I pull out the information I need and I start to work with it. Okay, so before I've even really done anything, I've read that problem at least 3 times. Okay, so again, I always recommend bring a highlighter. It doesn't hurt you. There's no rule that says you can't have one. So, all right, so it says there's 8 gallons of Gatorade in a container. So I got the 8 written down. I'm not sure what we're going to do with that yet. Sylvia fills cups with, and I don't know how many cups, so I think that's going to be my variable. Okay, so I'm just going to put C over here. With a half a gallon of Gatorade from the container. Okay, so for every cup I have, I need looks like I need, let me see. So a certain number of cups is going to fill half a gallon of Gatorade. Okay, so I've got 8 gallons I got to fill. I got a half a gallon. We filled that many cups. Okay, so it says write an algebraic expression to represent the situation. Use C to represent the number of cups. Okay, so we already figured that out. We didn't know what C was. And then it says use your expression to determine how many gallons of lemonade are left if Sylvia fills X amount of cups. Okay, so let me see here. Let me see. So there's 8 gallons of Gatorade in a container. Sylvia fills cups with half a gallon. Okay, so I'm trying to figure out. Fills cups with half a gallon of Gatorade. Okay, yeah, this is kind of a funky question. I'm not sure if I like this one. Okay, use your expression to determine how many gallons of Gatorade are left. Okay, so this to me sounds like the problem we did earlier in the day, if you were in my class, of course. Apparently we have some 7 red students joining us today, which is pretty cool. So I do not like this question. I really don't. This is bothering me. But I'm looking at the one on your test, and it's not going to be as ambiguous as this one. So, let's see. What is wrong with me tonight? Sylvia fills cups with half of a gallon of Gatorade from the container. Okay, I don't like this question. I'm tossing it out. Moving on. This is the question that people were moving on to in class that we couldn't figure out because there's some missing information. My bad. Let's just get through this. Thank you, Bree, for keeping us on track. Yeah, I'm gonna pass on this one for now. Again, the ones we went over in class, very similar ones on your test. This one's a little bit too ambiguous. I think this could be interpreted a lot of different ways. So I'm gonna jump more into. I think we had a lot more questions on. Sorry about that, guys. That was a total waste of time. But anyway, we're going to talk about evaluating expressions. I feel like that's something that we didn't go over a whole lot in class. Again, sorry about that last problem. I don't know why that. It's either my mind's not working because I'm paying attention to too many things, or I just don't like the way that it's written, and there's not going to be one like it. So it says evaluate each expression by giving the values for y. Okay, so we're going to talk about a problem. Let's say you have a negative 2y plus 7. So when you're being asked to evaluate an expression, all you need to do is plug in whatever values they give you for that expression. Okay, so in class we might have seen a table. Okay. All right. So here's your y value. Okay. And then over here is the result of negative 2y plus 7. Okay. So any number that we plug in for y, we can evaluate the expression with and get an answer for. Okay. So it's like that cause and effect, or that input-output machine that we've done in class before. Okay, so let's do a couple of different values for this. Let's say we're going to evaluate for 4. We're going to evaluate for negative 1. We're going to evaluate for 2 and negative 3. Okay, very inventive numbers, as you can see. So all we're going to do when we're supposed to evaluate the expression is we're just going to plug in these values for y and then solve. So our first one we're given is 4. So when y equals 4, what do we end up with after we run it through this equation? So again, step one is you write down the expression. Okay, I know it's right there, but we're going to write it down again. Okay, so we're going to make sure we're setting things up correctly. Okay, so again, same exact expression. It's right there. Okay, and I'm going to erase this one. Okay, because that's the one I'm going to work with. Okay, so step two is we plug in the information we're given. So we're given a value for the variable. We're given 4. So we're going to plug that in. Okay, and I always recommend leaving it in parentheses. It doesn't look necessary right now, but when we get to the next one, you'll see why that's important, especially after what we just learned with negatives. So step 1, I write it down. Step 2, I plug in what I have. And then step 3, I solve using order of operations. Okay, so order of operations says that I have to do, it's PEMDAS, right? You guys have seen this before? Okay. And this stands for parentheses, then exponents, okay, and then multiplication / division, and then addition / subtraction, okay? So I have to do these in this order, okay? And I know you've been over this in 6th grade. That's just the rules of mathematics. You have to do certain things before you can do other things, okay? So we want to solve what's in the parentheses first. Okay, I do have parentheses, but there's only a number in there, so there's nothing I can really do with that. Okay, I have no exponents, all right? But I do have some multiplication, okay? Because when a number is next to parentheses, that means we're going to multiply whatever's in the parentheses. So it could be just a 4. It could be an additional expression, and that's where the distributive property is going to come in. So we're not quite to that point yet. Okay, so I'm going to multiply first before I add. So -2 times 4 is a -8. Okay, because 2 times 4 is 8. Negative times a positive is a negative. Okay, so -8 plus 7. Okay, and if I have a -8 and I have a positive 7, I wind up with a -1. So when y equals 4, this expression is going to equal -1, and that's how we evaluate it. Okay, so I can't. So again, I do have to do every single value here. So I'm going to do the exact same thing, but just plugging in different numbers for y. Okay, and again, I don't have an equal sign, which is why this is an expression. If it had an equal sign, it would be called an equation. Okay, because remember, the word equal, so there's equal. The word equal is in the word equation. Okay, so if you saw that, feel free to rewind that a couple times. I thought that looked pretty cool. Okay, so an equal sign would mean that there's an equation, but we don't have an equal sign. Therefore, we have what's called an expression. Okay, so just some quick vocab that we should know by now, but just going to go over again. Okay, so again, we're evaluating this. We're plugging values in. I had an eraser somewhere. Hold on. Stand by. Oh, here we go. Okay. Anyway, so now I'm just going to do the same process again. Same equation, or same expression. See, there I go, mixing them up. Okay, so again, I'm going to plug in my next value for y. So I write down the expression that's already there. Okay, and we already should know what this means, so I'm going to get rid of this. Just got a lot of clutter on this little 4-year-old's easel here, so I'm trying to clean it up a little bit. There we go. All right, so next I'm going to plug in -1 for y. So I have a -2 and a -1 plus 7. Now again, here's where those parentheses come in handy, because it keeps me from making a mistake of thinking I'm subtracting or from forgetting the negative sign. So when you keep the number in parentheses, you're acknowledging that you have a -1 here. So again, a negative times a negative is going to end up equaling a positive. So if we don't do that correctly, it's going to impact the answer. So we have to make sure when we plug anything in for the variable, put it in parentheses. And it's just easier, and again, include your negative sign if you need to. So you have a -2 times a -1, which is a +2 plus a 7. Okay, and then my answer ends up being 9. So when y is -1, okay, or when y is -1, this expression equals 9. Let me see. It's pretty quiet in the chat today, man. Last time I was getting flooded with random nonsense. So thanks for keeping things on track. I appreciate it. And again, if you guys have any questions about this, the point of being here is to ask questions. So if there's something that's confusing you or something I said that lost you, definitely ask me. That's what I'm here for. -2 times -1 is the equivalent of 2 times 1, correct? Yes, it is. Because again, 2 negatives end up equaling a positive, just like 2 positives would equal a positive. So yeah, so same. You end up getting the same thing. But again, it's important to understand what to do with these negative signs when we start talking about the distributive property. So they are something to keep track of. So it's not a direct comparison, but they just end up equaling the same thing, if that answers your question. So let's do this again. We got 2 more to do, and then we're going to move on to probably some of the more difficult stuff, combining like terms and distributive property. Evaluating expressions is pretty self-explanatory because we just take a value, we plug it in, and we get an answer. So that's all we're doing. Regardless of how it looks, and the test will give you different values to plug in. So it'll give you what you need to solve the expression. So now we have a positive 2. Okay, so we're gonna we wrote down the expression. We're gonna plug in the value, which is 2. Okay, and we're gonna go ahead and evaluate the expression using the order of operations. Okay, so again, I have to multiply before I can add. So negative 2 times positive 2 is a negative 4 plus 7, and a negative 7 plus, or sorry, a negative 4 plus a positive 7 equals a positive 3. So when y is 2, x is going to equal, or sorry, when y is 2, the expression is going to equal 3. So, okay, let me see. Answered. Question answered. Oh, gotcha. All right, thank you. Good. Glad to hear that. Okay, and the last one. And again, I know it might seem like in some instances I'm going kind of fast. The reason I'm going fast is because you can always pause this after the live stream ends, and you can always go back and rewind and watch it again. So if it feels like I'm moving a little faster, that's the reason. Last year we learned, please excuse my dear Aunt Sally. Yeah, same. That's oh man, what do they call that? Acronym? Is that an acronym? I forget what they. Well, acronym would be PEMDAS, but yeah. So yeah, same idea. I believe it's an M there, Mr. Fine. But anyway, yeah, same idea. And again, those are tricks to kind of help your memory. Because again, you brought that into this year, and that's something that you know. So that's why we teachers give you those different tricks. So last one. Apparently, I don't get fancy enough though. So negative 2, and I'm plugging in a negative 3. All right, plus 7. All right. So again, I have a negative times a negative, so my answer is going to be positive. Okay. So 2 times 3 is 6. Negative times negative is positive. Okay, bring down my plus 7, and a 6 plus 7 equals 13. So when y equals negative 3, the expression is going to equal a positive 13. It actually isn't. All right, well, let's not argue too much about a incorrect letter. So perfect, looks great, Mitchell. See, you redeemed yourself. Nice job. All right, so I think we're done here. I think we've done what we can. And so again, this is evaluating expressions. So, you can, again, after this live stream is over, if you want to scrub through that again, you're welcome to do that. Let me see. So let's see. We talked about evaluating expressions. First problem failed. Let's talk about the distributive property. Okay. So next order of business. All right. Distributive property. Okay, so that's our focus for now. And I feel like my camera is kind of drifting upward. There we go. Yeah, it's a little better. That's the one. So distributive property is a property of multiplication and division that allows you to, if you're multiplying a whole expression, you can multiply the same number to different parts of that expression. And same with division. If you're dividing a whole expression, you can divide each part of the expression by the same thing. Oh, thanks, man. I appreciate that. It's a sweet cursive. I should probably bust that out more. What is going on with my camera? It's just like starting to, oh gosh. All right. Sorry, there we go. Sorry about that. A lot of technical difficulties tonight. So yeah, I think I fixed it. It looks like it's hanging tight. So I was streaming the other night. I streamed Fortnite the other night, much to my dismay. And I messed with all my settings, so now I'm regretting that. Okay, anyway, so distributed property, let me give you some examples. So if I have a 2, and I times this by, let's say I times it by a, let's say it's 9x minus 6, okay? So I can evaluate this expression. Well, I can't really evaluate it because I'm not given a value for it, but I can make an equivalent expression where I distribute the 2 to each piece to possibly make that easier to work with. Okay, it kind of depends on the situation here, but you are expected to use the distributive property and also to factor out, so to go the other direction. So these are, you want to know how to distribute, but you also want to know how to undo the distributive property. So we're going to talk about both. Okay, so in this case, because I'm multiplying 9x minus 6 by 2, I'm multiplying the whole thing, I can actually multiply each piece by 2 separately. Okay, but here's the hardest concept that I find that 7th graders have, is they're not seeing this as a negative 6. This is a negative 6. You just learned how to add, subtract, multiply, and divide negative numbers. And the reason being, you had to learn that and the rules of that before you could learn expressions, because when you are dealing with subtraction in expressions, you're actually dealing with a negative number. So, for example, if I change, well, I'm gonna dig into that. I will. I'm gonna come back to this. Okay, but let's hold on this problem for now. Okay, but let's just understand why you're able to do this. Let's say I have a negative. I have a let's see. I have 1. Let's say I have 1 minus 9 plus let's say 16. Okay, so let's say I have these 3 numbers. Okay, now when you were in the younger grades, so like 4th grade, which I used to teach, okay, you were told that the commutative property of addition, which I'm going to write down here, the commutative property, and this is another one that you should know, and the community, okay, is going to treat you as though you remember this property. Okay, but the commutative property tells us, so it's the commutative property of addition. Okay, there it is. Sorry about my handwriting tonight. There we go. Commutative property of addition. Okay, the commutative property of addition says that we can add things in any order and it doesn't matter. Okay, so whether I add 9 plus 16 or 16 plus 9, it doesn't matter. However, we were also told at a young age that we cannot change the order of subtraction. I can't just do 9 minus 1 or 1 minus 9. That's still true. Okay, you can't change the order of subtraction. However, again, once you know the rules of mathematics, you can start to bend them to your will. Okay, so in this case, if I'm subtracting 9, another way to say this is that I'm adding a negative 9. Okay, it's the same thing. If I'm taking 1 and subtracting 9, or I'm taking 1 and adding a negative 9, that ends up equaling the same thing. So we just talked about the fact that the commutative property addition says that you can add numbers in any order and it doesn't matter. Well, now that I've changed this minus 9, okay, into adding a negative 9, now I can switch the order around as much as I want. Okay, I kind of lost you. Well, sorry, Felipe. I didn't mean to lose you there. My point being, one of the rules that you learned already is that when you are subtracting a number, it's the same as adding a negative number. Okay, that's all I'm saying. So what's nice about that is now I can rearrange things in any order and it doesn't affect the problem. Okay, so making the whole problem addition can be beneficial, and that does allow me to move terms around. Okay, so now it doesn't matter what order I add these in because I'm adding a negative 9. I'm not subtracting. Okay, so again, we'll talk more about that as we get into this. I lost a lot of people on that one. I'm sorry about that. It's just a rule that you need to understand that you can change this. So let's go back to this problem. Let's rewind a little bit. I'm going to save the commutative property of addition. Okay, we're going to leave that there because it does become important when we're messing with expressions. Okay, so let's talk about this problem that we have up here. Okay, so we'll keep it simple for now and just bear with me. Okay, it's because you changed I shouldn't have touched it. Should have left it alone. Okay, but again, it's going to come into play right now. So the distributive property says that I can multiply each of these terms separately, so that way I get rid of the 2 and I get rid of the parentheses. It makes everything look a little simpler. Okay, so I can give a 2 to the 9 and a 2 to the 6. Okay, but I still have to keep this subtraction here. Okay, and we'll talk about when that can change later. Okay, so a 2 times 9 is 18. Okay, and don't forget your awkward x. Okay, they follow you everywhere, right? Gotta leave you alone, everyone, but this one just keeps following you, right? Okay, so 2 times 9 is 18. You bring the x with. 2 times 6 is 12. Okay, and I'm subtracting that 12. Okay, so I've used the distributive property. I've changed this problem. That's it. Okay, I just give a 2 to each of the terms, and that's it. All right. So not sure if you have any questions about that. We're going to do a couple more. And again, this is where things will start to get a little complicated because I'm going to start talking about negatives, which again, we should feel pretty good about. Okay, so I'm going to do one more simple one because I feel like I scared you guys a little bit. It's really not that bad. Okay, so let's say I have a 4 times let's say I have a 3x plus 1. Okay, so all the distributive property says is that I can multiply each term by 4 separately, and I get rid of the parentheses, and I get rid of this 4 on the outside. Okay, so a 4 times a 3x is a 12x. Okay, it's positive, and a 4 times a 1 is a 4. That's it. I'm done. That's all I have to do. That's what the distributive property says. Okay, and it also works for division. Okay, but I'm going to finish up with multiplication before I get there. Okay, if they don't go into each other, is the greatest common factor 1? Oh, so let's say both, like you're saying, if both of these terms don't have a common factor, then you actually can't really do anything with it. So I can't go back the other direction Well, I'll talk about it. I see what you're saying, Alex, and I'll go ahead and I'll dig into a situation where what you're talking about. So let me think here. Okay. So again, I have the 4, I distribute it to each piece, and we're done. Okay. But we have to understand with the distributive property. Okay. So I'm going to use the same problem here. Okay. I'm going to use the same problem a couple times. Okay. And again, I'll get to the GCF in a minute. Okay. It's greatest common factor, but we'll talk about that in a second. Okay. So in this case, what if I had a -4 here? Okay. So now we're going to do the same exact problem. We know the numbers, but now we're going to talk about negatives. Okay. Let's say I have a -4 out here. That ends up changing this problem pretty significantly, because now what's going to happen is I'm going to have a -4 times 3x, which is a -12x. But I'm also going to have a -4 times a positive 1, okay? Which means I'm actually going to have -4 times 1, which is adding a -4, right? Right? So now we got all this mess, right? Well, another way to look at this is what I was trying to say earlier, but I think I confused you. This is still not really very nice to look at. There's a lot going on. So what we have to realize is that when we're adding a -4, it's the same as subtracting, okay? So that being said, another way I can say this expression is that I have a -12x minus 4. Okay, so I had a negative out here, but a positive in here. So what ended up happening was it changes the sign. Okay, so I ended up getting a -4. Okay, and that's what I was trying to explain earlier, but I probably did a bad job when that happens. Okay, so that's what happens there is if you have a negative here, when you distribute it, this number became negative, but so did this one, and that actually turns the sign from addition to subtraction. I can still leave it like this, but when we're looking for something, when we're dealing with expressions, we want to leave things as simple as possible. So for my students, I would say that I would expect to see this, because we should know better. Okay. So now things are about to get a little crazier here. So stay with me. Okay. Let's say, I mean, really not that crazy, but now we're gonna turn the tables here a little bit. I've still got a -4, but let's say I have a -1. Okay. Or let's, in this case, well, yeah, it's a -1, but it's also a -1. Okay, same thing. So I still have a -4 out here. Okay, so we're going to do this problem again, but again, we're adding some different negatives, different signs, and we already know the numbers. So, but watch what happens to these numbers. Okay, so again, -4 times a positive 3 is a -12, and I bring the x. Okay, but again, now I have a -4 minus 1. Well, if I have a minus here and a -1, then that means I'm going to end up actually having a positive answer. So I'm going to be adding it. Okay, so a negative times a negative is a positive, and a 4 times a 1 is a 4. Okay, and again, this is what I was trying to explain earlier, but it might get a little confusing, so bear with me here. So some of you might be wondering, well, how did that happen? That you're subtracting a positive 1, right? You're subtracting a positive 1. But again, that's the way that you have to look at it is it's the same as adding a -1, right? Okay, and we kind of go back to the same argument we had last time, right? So -4 times a -1 ends up being a positive 4, right? -4 times -1, positive 4. So that's why the sign changed from a minus sign to an addition sign. So I know a lot just happened there. So if you have any questions about that, feel free to let me know. I'll take a quick break here because I gotta actually I gotta fix a few things here. I need to take a sip of water. My daughter got me the sweet water bottle. That's awesome. And I don't know. I feel like my lighting's a little funky. So I look a little blue. Oof, it's a little much, but at least I'm not in the shadows anymore. So good production quality means you have good lighting. So how do you know if you need to change the sign, or do you always change the sign? You don't always change the sign, and the way you know is remembering what happens when you multiply a negative times a negative, or a negative times a positive. Okay, so I'll do another example there for you, Leah. Okay, so we'll do another one for you. I'm gonna use different numbers. Okay, and we'll talk about when that sign's gonna change. Okay, so I'm probably gonna stay on this topic for another 10 minutes or so. Do we have to change the sign on the test? Yes, you do, because again, that's part of understanding this property. Okay, so let's say I have a -3 times -2x plus, we'll say 5. Okay. So again, this just goes back to remembering what to do when you are multiplying by a negative. Okay, so I have a -3 times a -2 that we're going to bring the x with. We always bring the variable when we're multiplying. Okay, so a negative 3 times a negative 2 is a positive 6, and we bring the x. Okay, so now I have a negative 3 times a positive 5. Okay, so 3 times 5 is 15. A negative times a positive is a negative. Okay, so that's why I put a minus sign there. Okay, and the reason I'm able to do that is, again, subtracting 15 is the same as adding negative 15. Okay, so I maybe had a negative 15 here, but I can change this to be a little simpler by kind of clearing it up a little bit. Okay, and of course I should have waited till that dried. Okay, so I know that that's probably the toughest part of this, is that, like, when do you change the sign? Okay, I usually just leave the signs where they're at, and then I don't make things negative or positive. I'm just showing you that you can. But the way that I do it in my brain is I see a negative sign here, I see a positive sign here, so I should have a negative sign here. Okay, in other words, I should have a minus sign, a subtraction sign. Okay, so again, the negative times the negative here got me a positive. The negative times the positive got me a negative. Okay, I hope that makes sense. Yeah, changing the sign, like I said, once you see it, once you see the pattern to it, it just clicks. So don't sweat that too much. So let's talk about division, because division is also going to be on the test. And division also works the same way. And I'm going to show you the way that I see it. There's a couple different ways that you can approach it. But the way that I see it, I think, may help make sure you don't miss any steps. Do you think we'll do? I think we're going to do pretty well on this test. I think the positive and negative numbers was a little tougher. But I think this test we're going to do pretty well on, because it's kind of a new concept. And I feel like there is a lot of, I feel like things are moving along pretty nicely. So it's just, again, it's a matter of effort. It's a matter of preparation. Okay. It's, I like to think I'm pretty good at wrestling. Okay. But if I don't practice for 6 months, and if I don't, learn anything new, or I don't add to what I'm doing, well, people are going to get better than me, and I'm going to get beat eventually. Okay. So I got to go to practice. I got to work hard. I got to get my conditioning up. It's the same thing with math. You got to practice this stuff, and you actually have to, work with it before it actually becomes more of a habit, and you really feel confident with it. So let's talk about division. Okay, let's see. So let's say I have 36x minus, we'll say 12, divided by 6. Okay, don't freak out when you see fractions. Okay, fractions, believe it or not, are your friends. Okay, I used to hate fractions. They drove me nuts. I didn't understand them. I didn't understand what I was supposed to do with them, and I never wanted to see them. I loved decimals. But then the older I got and the harder math got, I learned very quickly that fractions are your friends. Oh my gosh, fractions make things so much easier as long as you understand what to do with them. Okay, so in this case, don't freak out. Okay, you have to look at fractions as a division problem. Okay. So in this case, we have a division problem. It looks like a fraction, but it's a division problem. I have 36x minus 12 divided by 6. Okay, and I can make this simpler. Okay, and the way I make this simpler is I can use the distributive property to divide each of these terms by 6. I mean, if I'm doing it together. So I want you to rewrite it like this. Rewrite it separately. So I have 36x over 6 minus 12 over 6. Okay. Now again, these aren't fractions; these are division problems that I can reduce down. Okay, because when we have fractions, we usually want to reduce them to the lowest terms, right? So, and the way you do that is you take the top divided by the bottom, right? So in this case, I can do that. I can take 36 divided by 6, and I get 6. Okay, you bring the x with you. All right, I have a 12 divided by 6, which ends up equaling 2. So this reduces down to 6x minus 2. Okay, and again, the reason I can do that is 6 goes into both of these numbers. Okay, it is a factor of 12, and it's a factor of 36. I didn't change the sign here because 6 was positive, and a negative divided by a positive still equals a negative, so I still have a minus 2. Okay, is there any way we apply exponents? Not really, no, not a whole lot of exponents here. The only thing we have to watch for, which we're going to talk about when we start combining like terms, is to make sure that we're not combining variables that have different exponents. That's really the only thing to deal with exponents. But again, that's a rule that once you grasp it, you're good to go. Okay, so that's what happened here. We're going to do another one just like this, but with some different numbers, and we're going to throw in a negative sign. Okay, so let's say I got a negative 16x plus 8 all divided by let's say it's a negative 2. Okay, so I got a negative 2 now. Okay, I'll get back to you on that question. I got to count. And Felipe Fructose, yes, those are the same thing. Either one is correct. I just like 6x minus 2 because it looks nicer. It's just there's less of a chance for that to get mixed up. But anyway, so I have a 16x plus 8, and I'm dividing that all by a negative 2. Okay, so all I'm going to do is I'm going to split these up. Okay, so negative 16x divided by negative 2 plus 8 divided by negative 2. All right, so 16 divided by 2 is 8. Negative divided by negative equals positive. So now I have a positive 8x. Okay, and I'm adding this to 8 divided by negative 2, which ends up being negative 4. And again, a cleaner, neater, less symbols way to write this is to have 8x minus 4. Okay, so you see how that, I mean, they're the same thing, but that's just so much nicer to look at. Okay, and again, as you get older, you'll have to do things further with that, so it's a good concept to understand now. It just keeps you from overcomplicating things. There is one more situation I want to talk about with the distributive property. Someone asked about exponents. I don't see a whole lot of this on the test, but I do want you to have just to think about it and understand it. You can have a variable on the outside of the parentheses. Okay, so let's say you have a q. Okay, and I'm timesing a 4q minus 2. Okay, the distributive property, you still can distribute a variable. Okay, but we have to talk about what's happening when you do that. Okay, so if I distribute a q to both of these, okay, I have a 4q times a q, right? Minus 2 times q, which is 2q. Okay, we got a lot of q's going on here. Okay, and a q times a q. Let's talk about what that really is. You don't want to leave this here because this is not a reduced answer. Okay, if I have 6 times 6, another way I can write that is, yes, that's correct. You can write that as 6 squared, right? When you have 3 times 3, you can write that as 3 squared. Okay, well, when I have q times q, okay, I would write that as a 4q squared minus 2q. Okay, so q times q actually would be q squared. Okay, just like 6 times 6 is 6 squared. Okay, the only difference is these are numbers we know, so we can actually solve 6 squared. Okay, whereas q squared, we can't solve that. We don't know what q is, and it could be any number because it's an expression. We can plug in any number. So we have to know that we're multiplying it by itself. That is not the same. Here's the key. That is not the same as 2q, okay, because I'm just taking q timesing it by 2. Whereas here I'm taking q and I'm squaring it. I'm timesing it by itself. Okay, so those are two different things we have to understand. Okay, so just keep that in mind, that when you're multiplying a variable by a variable, the same variable, you're going to end up squaring that variable. Okay, and for the reasons we talked about. All right. Uh-oh, my easel's starting to fall apart a little bit here. Okay, so again, these are things to know because now we're going to start talking about combining like terms. And if numbers have different exponents, then you cannot combine them. Okay, so there are a couple times where I'm going to talk about when you cannot combine like terms. Okay, so I should take that back. When you cannot combine terms unless they're what we call like terms. That means they have the same variable expression, and that's a really key term to understand. I didn't say same variable. I said same variable expression. Okay, so if I have a 7x, and again, this really applies for addition and subtraction. Okay, multiplication and division, you can put terms together that are different, but with addition and subtraction, you have to have the same. The terms have to be the same. They have to have the same variable expression. And let me talk about what that means. Okay, so if I have a 7x, okay, plus a 2x, all right, I can actually reduce this. Okay, I can combine these terms because 7 has an x, 2 has an x. Okay, so what I can do is I can combine these and say that I have 9x. And let's think about if that's true. So I have 2 x's here, right? Because I have 2 times x. I have 7 x's here, right? 7 times x would be 7 of those x's. So it's reasonable to say that if I had 2 x's and I added them to 7 x's, well, then I'd have 9 of those x's. Okay, so that's the reason we can do that. What happens when you have, when you have 2 different variables? And that's kind of what we're going to get into here. So pay attention to this here, okay? So I'm going to change one of these, okay? I'm going to change that to a y, okay? So 7x plus 2y, can't do that. Okay, I can't put them together and say that I have 7x. I can't say I have 9xy or whatever weird thing we're going to come up with. I can't do that. I can't add these together. Okay? And again, that's because they're not like terms. They have a different variable expression. In this case, they have different variables altogether. Okay? Yeah, if it's not multiplication or division, you can't really mess with it. So that being said, Mitchell asked a question. What if you had two different variables? And it looks like you actually answered your own question. Yes, it would be. So let's say I was going to multiply these two together. Okay, I would have 7 times 2. Again, these are called coefficients. Okay, the numbers attached to a variable are called the coefficient. So I have two different coefficients here. So I would multiply the coefficients together. So 7 times 2, which is 14. And then I would tack on an x and a y. Okay. Remember, the variable is like your awkward friend at a party. It's your introverted friend. They want to be at the party. They want to be around the atmosphere, but they just don't want to they don't want to mingle with people. They just kind of latch onto you because you're the only one they know there. Okay. So, wherever you go, they go. No matter who you start talking to, no matter who you start playing video games with or whatever, kids in middle school do, they're just right there next to you. Okay. So the variable always goes with the coefficient, its friend, okay, because they can't handle it. It's the only person they know, okay. So when these two want to hang out, that's great. They become 14. These two want to hang out. Well, they just kind of hang out awkwardly on the side while these two talk, So that's kind of how that works, okay. So yeah, so when you have two different variables, if you're multiplying them, you can put them in the same term, but if you're adding them, you cannot combine them. It just has to stay. Okay, it just has to stay as 7x plus 2y. This is it. This is done. Okay, it's as far as we go. Okay. So another instance where you cannot combine like terms, okay, at least not right away, is let's say you had 7x plus a 2x plus 1, okay? So I can't combine these yet, okay? I'm lost. It depends what it tells you because you could also have, well, yeah, but we'll get there. Do you always add them? No, you don't always add them. You could be subtracting them as well. In fact, let's do that. Let's subtract them just for fun, okay? So here's the deal. I have a 7x minus a 2x plus 1. I'll tell you what, Leah, let's leave it addition for now. We'll come back to that. I don't want to make this more complicated than it needs to be, but that is something that we'll talk about. So I've got a 7x plus a 2x plus 1. I can't combine these terms. Okay, sure, we have an x here, but again, it's a different variable expression. Here I just have x, but here I have an x plus 1. I have something that's different attached to the 2. Okay, so in order to combine these terms, what I would have to do is I would have to use the distributive property to get the parentheses to go away, to kind of break break that variable expression up. Okay, so in this case, I have a 7x, okay, and I'm adding a 2. I'm going to distribute this to each. So I'd have a 2x plus 2. Okay, so now I can combine the like terms I have. I have a 7x and a 2x, which ends up being a 9x. Okay, but I can't do anything else with that 2. Okay, that 2 doesn't have a variable attached to it. It doesn't have an x attached to it. So the best I can do is just kind of leave it there in the end. Okay, so that's all we can do there. Which channel do you stream for now? Oh, well, that's a different topic. We can talk about that later. But right now, we got to stay focused on math. But anyway, so again, we had two different variable expressions, and I was able to distribute to get the parentheses to go away, so I could combine them. But again, I can't do anything with the 2 because there's no variable. So in another instance, okay. All right, let's talk about this. This is where things get a little funky. Okay, let's say I have a 7x, okay, plus a 3x squared. Okay, now they both have an x attached to them. I mean, it seems reasonable that you'd be able to put them together, but guess what? You can't do that. Okay, because again, you have a different variable expression. This is just 7 times x. Okay, I have 7 times x, but over here I have, oh, my voice did a really funky crack there. That was weird. I have 7x plus 8. Remember, x squared means x times x, right? So again, that's a different variable expression. So I can't put these together because they're different, okay? So that doesn't exactly work the way we want it to. So remember, x times x ends up being x squared. So I can't add, even though they have the same variable, I can't add them because they have different exponents. Okay, this one doesn't have an exponent. This one has a 2. Okay, let's say I had another one just to be crazy. Let's just go nuts. Okay, let's say I had a 2x to the third. Can't do anything with that either. Okay, because this is x squared. That's x to the third. They have different powers, so I can't add them together. Okay, so these are not like terms. So these are non-examples, we call them. Okay, so we're going to start getting into a situation where you have terms that are like, and let's say they're just kind of all over the place. They're kind of crazy. I'm behind, but I like when you said let's just minus the yeah, why not, right? I'll come back to that because I know that's a question. Does it matter if you're adding or subtracting? It does matter, and what you do with it matters, but again, we'll kind of get into that. So you couldn't just combine the x times x. No, you cannot. I know it seems so I know it seems kind of weird. It kind of feels like you should be able to, but you can't. So and again, as we get more into this unit, we'll talk more about the reasons why. For right now, you really just want to focus on the fact that if it has a different exponent, you can't add them. Okay, so they are different terms. Okay, so I got to think about where we're going next here. Oh, okay. So I think that kind of explains. I think that explains like terms in terms of what in terms. So I think that explains what you can't do with like terms. So let's start talking about where like terms come in handy. I got to think about a problem where this is really helpful here. So let's see. Let's say you have 4x minus 3 minus we'll say 2x plus 6. Okay, let's say you have a problem like this where you have a bunch of random numbers here. Okay, and you have some that have an x attached to them, some of them that you don't. Okay, so this goes back to that commutative property of addition. Okay, where I like to put terms that I like to put like terms next to each other. Good, that's good. I'm glad that you're taking notes. Again, that'll be helpful for making a note card and get some questions answered tomorrow during our review. So again, I see some like terms. I see 2 that have variables. I see 2 that don't. Okay, so the first thing I like to do is I like to get like terms next to each other. Okay, so I told you earlier that if you're subtracting a number, it's the same as adding a negative number, right? I'm adding a negative 3. I'm adding a negative 2x. Okay, the reason I do that here goes back to that what I had here, the commutative property of addition. The commutative property of addition says that I can change the order of an addition problem and it does not affect the answer. Okay, we were told when we were little that you cannot change the order of a subtraction problem. I'm telling you now you can. However, you have to change it all to addition in order to change the order. And when you change a subtraction problem to addition, what you end up doing is you're adding a negative of that number. So that's why I'm doing that, and that's the purpose. Okay, because now watch what's going to happen. Okay, so now I can move this all around. Okay, so I have 4x plus a negative 2x. Okay, and I have a plus a negative 3 plus a 6. Okay, so now I was able to change the order. I was able to put like terms next to each other. And now I can combine this to make this a little bit easier to look at and to understand. Okay, so in this case, I have a 4 plus a negative 2x. And again, that's the same as 4x minus 2x. So we get a positive 2x. 4 minus 2 is 2, and we keep the x attached. Okay, awkward friend of the party. Okay, my third grade teacher lied to me. No, they only told you what you needed to understand at that moment. Okay, when my 4-year-old daughter asks me, a tough question, I could give her the correct answer. Okay, so if she asks me why, I don't know, let me think of a question. Why is the sky blue? Well, I can get into the whole discussion of how O3, reflects blue light and that we have an ozone layer and there's different layers. She's not going to understand that. For right now, the sky is blue. Deal with it. You'll learn when you're older, because if I try to explain it, I could explain it in 4th grade, in 4-year-old terms, but it's probably not gonna answer the question. If I explain it in college level terms, that's not going to make sense either. Okay, you gotta learn to crawl before you can walk, and you gotta learn to walk before you can run. Okay, so your 3rd grade teacher did not lie to you, I promise. They only taught you the rules that you needed to know at that moment. Okay, because now we're at this point, and now we understand that subtracting a positive number is the same as adding a negative. So now we can do more. Okay, so we're kind of building on that foundation. And again, if you guys want me to keep going, I am willing to keep going. I see that some of you are a little worried. You see that we got 10 minutes left. Maybe you have some questions. I've got a little extra time. I always do this to myself. Okay, but let's get back to the problem at hand before we get lost here. So the first thing I did was I changed everything to addition, and if I was subtracting, I made sure I'm adding a negative, and I rearranged the problem so that like terms are next to each other. Okay, so now I can start reducing this down. Okay, a negative 3 plus a positive 6. Okay, again, it's the same as 6 minus 3. So I now have a positive 3, right? 6 minus 3 is 3. Negative 3 plus 6 equals positive 3. Okay, so my final answer is 2x plus 3. And so the reason that we combine like terms is, sure, I could plug in something for x, and I could mess with all 4 of these, or I could simplify the expression and plug in a number for x, and man, that is way easier to work with. Okay, so that's the purpose of combining like terms. Okay, but 4x and 2x are not like terms. Actually, they are. They are like terms, and again, they're like terms because they have the same variable expression. They have a 4. They both have an x, just a regular x attached to them. 3 or negative 3 and 6 are also like terms because they don't have any variables attached to them. So that's something. So in that case, we can actually combine those two as well. Okay. So let me see. Okay. Yeah. No. But again, see, and I love that. I love that you're saying what you think is correct, because if it isn't correct, that's why we're here. Is that we can talk about. We can kind of rewire our brains. We can change our way of thinking. And I see some people in the comments that are actually kind of helping out and explaining how they're understanding things. And that's what it's for. I mean, this is so cool. We have the technology at our disposal to communicate and to collaborate with one another. So it's really cool that you guys tuned in and that you're involved in the discussion. And the last 2 live stream reviews actually had a lot of distractions, a lot of funky off-topic comments, and I'm not seeing that this time. And so I feel like this has been a lot more productive as a result. So I do appreciate that from you guys. Thank you. So let me see. I'm going to scroll down. I'm going to look at the. Let me see here. Okay. So you will have to find expressions that are equivalent. I'm not going to go into too much detail, because again, that kind of comes from evaluating expressions and using the distributive property, which is what we're doing, to find expressions that are equal to one another. Okay. So it'll be up to you on the test to evaluate an expression, simplify it, and then see if you could find an answer that's equivalent to it. So what if there is 2 variables? So if there's 2 variables, well, let's talk about if there's 2 variables. Okay, which on the test there won't be. But again, if we're going back to the rules of this, let's say I have a y here. Let's say I have a 6y. Okay, so now again, I put like terms next to each other. So I have a 4x plus a negative 2x. Okay. I have a plus 6y, and I have a plus negative 3. Okay. Well, I can still combine these two. Okay. 4x minus 2x is 2x. I don't have any other y terms, so I got to keep the 6y. And I don't have any numbers that don't have that don't have a variable attached, so I can't do anything with the plus negative 3, which again we can write as a subtracting 3. Okay. So in this instance, if I have a different variable, it just means that I can't combine it with the other terms. Okay, so I can still combine the x's, but I can't really do anything with the y because there's no other y's to put it with, and I can't do anything with the negative 3 because there's no other numbers that don't have a variable. So let me think here. And again, I'm trying to make the most of our time here by figuring out what we're going to have to do. So there are times here where you're going to have to factor out. So some of us were asking about the greatest common factor, or the GCF, right? Okay. So there will be problems on your test where you will be expected to kind of undo the distributive property. So I want to talk a little bit about that. Let me just double check on some of the questions here. Okay, so do we have to do the distributive property, commutative property, and like terms in all the problems on the test, or are they? There'll be some where you do each of those separately, but there'll be some where you have to evaluate the whole expression, but you have to know those rules. Okay, which again you can do. You can do these things. These are just once you know the rules of it, then again it just takes a difficult expression and lets you make it simpler bit by bit. Okay, so again, I'm going to talk about when you factor out a number. So let's say you have, I feel like I keep taking 12. I'm going to do 15x plus 25. Okay, so we're going to start off a little simpler here. Okay, and we will. I see a lot of people asking about word problems. There's the word problems that we did on Cami today are very much like the ones you'll see on the test. Okay, so I didn't want to go over those because we did spend time in class today doing problems like those, and there'll be problems like those on our review tomorrow. And since those are the only types of word problems, we're just going to let those be. I feel like we're ready enough on those. And again, we can ask questions in class tomorrow on that. So I really want to kind of focus heavily on being able to manipulate the expressions. So Is it sad that I didn't know he meant? Well, it's not sad. I mean, this is just a C. He could have interpreted that anyway. But anyway, here's the deal. I have a 15x plus a 25. Okay, so right off the bat, we should be able to tell because they end in 5 that they have a common factor. Okay, so remember that the greatest common factor is what we're looking for here. Okay, so again, the greatest common factor is the number that you can multiply to get both of these numbers, and it has to be the greatest one. It has to be the largest one because that's going to simplify the expression the most. Okay, so in this case, I have a 15, I have a 25. Again, they both end in 5. We know that we can pull out a 5. So what you're able to do here is you're able to pull out a 5. Okay, and then you ask yourself, I found the greatest common factor between these two. So now how did I get from 5 to 15x? Okay, we have to multiply here. Okay, so what did I multiply by to get 15x? So 5 times, well, obviously there's an x there because there wasn't one here. I multiplied something here, I got an x. So there's an x here. Okay, so 5 times something gets me 15. Okay, and so obviously 5 times 3 is 15. Okay, so I pulled out the 5. Okay, put it out here. This becomes a 3x because 5 times 3x is 15x. Okay, I have a positive 25. So I have a positive 5, positive 25, so this answer has to be positive. And 5 times what got me 25? Well, of course, if we know our multiplication facts, we know that 5 times 5 gets you 25. Okay, so all we've done here is we've taken the distributive property and we've gone backwards. We've pulled out a factor that's common between the two. So we pulled out a factor, it's common between the two, and we found the greatest one they have in common. Okay, when will this end? It's a great question, man. I'm wondering myself, like, when will it end, right? No, I'm just kidding. I was going to end it at about 9 o'clock. I know it's 9 o'clock now, but it seems like we might have a few extra questions, so I'm willing to hang around for a couple more minutes if I need to. And I'm not talking about pictures right now. I didn't have the problems with the Cami word problems. Okay, yeah. So if you didn't have problems with the Cami word problems, you're probably good to go for the test. So let's talk about another situation here. Okay, and I'm gonna throw a negative in here as well. So let's say we have, I gotta think here. I'm starting to get tired, so my brain's not working as well. Okay, let's say I have a negative. Let me see. I gotta think. Hold on. Let's say I have a negative. Oh man. I don't know. A negative 6 minus 28. Okay, so we'll do a negative 6x minus 28. See, when I'm thinking about because again, I can't do the problems that are on the test. That defeats the purpose. Okay, but I have to come up with problems on the fly that we can use that are similar. But I also have to make sure that they're going to do the things I want to teach you. So I have to kind of stop and think about that sometimes. So I have a negative 6x and I have a minus 28 here, and I'm trying to find the greatest common factor that I can pull out and kind of undo the distributive property. Now, the first thing I notice here is that both of these terms are negative. Okay, so if these are both negative, that tells me I can pull, even if one of them is negative, I can still pull out a negative. Okay, but we have to be careful of what's going to happen to the signs here. Okay, so I have a negative 6 and I have a negative 28. So since both these terms are negative, I can pull out a negative number. Okay, but then I also have to think about what's the greatest common factors that they both have. Okay, it's not always the number that's attached to the variable. Okay, because if we know our multiplication facts, there's no whole number times 6 that gets us 28. Okay, so this is where you have to kind of remember those multiplication facts, which, I don't know, every day I taught 4th grade, I said, make sure you memorize your multiplication facts. Well, here you are, 7th grade. Hopefully you memorize them because this is where you need them if you want to do things quickly. Okay, but if we're not sure what to do, okay, what we can do is we can talk about the different factors that these two have. Okay, so think about all the ways that you can multiply to get 6. Okay, well, you can always do 1 times 6, and you could do 2 times 3, and there's nothing in between those. So actually, I found all the factors of 6. Let's talk about all the things you can multiply to get 28. Okay, I can multiply by 1 and 28. I can multiply by 2 and 14. Okay, I can multiply by, I can't multiply anything by 3. Okay, but I can multiply by 4. 4 times 7. Okay, and again, I kind of get towards the middle here. So I can't multiply by 5. Can't multiply by 6. And we've got the 7 there already. So I did find all the factors of 28. So again, we're looking for the biggest one they have in common. There goes that. Ugh. We're never going to use 1 because obviously that's going to bring us back to our starting point. So we have 2 in common. So that's a possibility. They don't have 3, they don't have 6, so I guess it's actually 2. Okay, so they both have 2 in common. Okay, and that's the biggest number they have in common. So that's the number we're gonna divide out of here. Okay, and again, they're both negative, so I'm gonna take out a -2. All right. So again, if you're not sure where to go from here, this is the way I do this, and this is the way I think about it, so that I don't make a mistake. Okay. So I realized that I found the greatest common factor. I put it out here. They both have a negative sign, so I pulled that out. So now all you have to ask yourself is, how did I get from a -2 to a -6x? Okay, so what do I multiply to get a -6x? Well, a negative times a positive gets me a negative, so whatever's here is going to be a positive answer. Okay, so 2 times 3 gets me 6, and obviously if I have an x attached to the 6, I must have had an x attached here to the 3. All right, so again, now I have to ask myself, how did I get from a -2 to a -28? Well, a negative times a positive is a negative. Okay, these are rules that we learned in the last test. So negative times positive is negative. So now what times 2 gets me 28? So we learned down here that 2 times 14 ends up getting me 28. Okay, we close the parentheses. Okay, so all I did was I just undo the distributive property in this case. I hope that helps. I know that looks a little confusing, and we can talk about all the reasons for why that's allowed. Okay, but you will be expected on your test to work with these kind of numbers and to work with both the distributive property, but then also going backwards and undoing the distributive property and pulling a factor out. Okay, so when we do that, we have to take the negative sign into account. Okay, let me see. All right, so we have hit the 1 hour mark. I know, right? That happens. That's like when the light bulb goes off. You're just like, oh, I get it now. Yeah, it's not that bad. So again, make yourself a note card. Make yourself a note card. And if you're from a different team, I know we have some 7 red students here. If you're not allowed to have a note card during the test, it's still good to make one anyway. Like, try to get all the information you can on one note card back and front. And that's just a good study strategy. It's going to help you think about what you're doing before you go into the test. And a lot of students, if they don't do that note card or they don't do anything like that, think about it. They go to class, they learn what they learn, they go home, they don't do anything involving math, and then they have to go take a test. Okay, that's not the best way to get your brain ready. Whereas before a test, if you sit outside of the environment of the classroom and you start putting notes on a note card, thinking about everything you might need for that test, putting it on a note card, having it with you the next day to kind of look at and refresh your brain, and then you go into that test, you're so much more prepared. And I'm telling you this not just as a teacher. I'm not even really telling you this as a student. This is actually something I wish I would have known before I got my college degree. And this is usually what happens at the end of the stream. I start to give you a little inspiration, right? I learned this when I went back to get my master's, and I actually learned this more so. I had a concussion. I used to do boxing and I do a lot of contact sports, and I had a concussion that it was a stage 3 concussion, so I actually went unconscious. And I was having trouble with short-term memory for a while. Like, there's this thing called post-concussional syndrome. I won't get into the whole thing, but for about 6 months or so, I was actually during my student teaching, I had a really hard time with short-term memory. And I learned that I was doing a lot of research on how to retain information because I was having a hard time doing that. Like, that should be simple, right? But the situation that I was in, I was in a boxing match and I got knocked out. And after that, I just had a hard time maintaining stuff. So I started looking up ways that we remember stuff. And what ends up happening is we actually remember stuff in the environment we learned it better. So, like, the stuff you're learning in math class, you go home and all of a sudden you're like, I don't understand any of this. But then you go back into math class and you're like, oh, I remember how to do this, because you associate the skill with the environment you're in. So the way that to retain the information is you almost have to learn it again at home. Okay, and that's why I structure homework, and that's why math is so important. Is you go home and now you almost have to relearn it, but now you've learned it in 2 environments. Okay, you've learned it at school, you've kind of rewired and learned it again at home or refreshed it at home. So now you know it in 2 environments, which means you're more likely to remember it. So again, I'm telling you that not as a teacher, not as a student, but as someone who had to overcome some issues with short-term memory. And I did the research, and that's just what you have to do. So I also remember too, when I was in college, sometimes we'd switch classrooms for classes, and it really was true where I'd remember, if I went back into the other room, I could remember what we learned, but I went into a new room and I couldn't remember it for the life of me. So your environment does play a big role in your memory. So that's why studying is important. And I don't just mean studying like just, oh, look at your notes. Think about what you're doing. Think about why you're doing it. do some practice problems, which again, if you hopped on tonight, that's what we're doing here. So you're already doing yourself a service to be successful on this test. So yes, there is wrestling practice after school tomorrow. Let me see what else. I know I missed a bunch of questions. So I went off on a tangent. I feel like if you tuned in today and you felt good about this stuff, you're ready. There are some things on the test that are going to be a little harder than what we talked about, but for the most part, you should be ready. You should be able to do the things you're asked to do on the test if you understand the rules that we talked about tonight. So, and Bree, we can talk about that separately. That's kind of not a math issue, but I'm happy to talk. If you want to shoot me an email or Mom and Dad want to talk to me, we can talk about that. Let me see. School doesn't suck. It's not that bad. Come on now. Let me see. How do you know? Okay, how do you know we do? I don't know. Okay. I'm reading the reverse order. I probably should have made my note card during this video. Well, remember, you can go back and you can do the note card. You can watch the video again and you can make your note card as you go. Let me see. Yeah, I haven't said you can't, so I'm going to stick with that rule. I think there's a low chance we have school tomorrow, but I might be wrong. Well, either way, I mean, as of right now, I can only bump the test back so far. So, I'm still planning on there being a test on Thursday. Wait, so, okay, let me see. How many? Yeah, you asked that a while ago. Let me look. There are 9 questions on the test. However, they have multiple parts. So if we're really talking about how many things you have to answer, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. There's like 30 little parts. But again, all of this stuff, I mean, think about how quickly we were able to do some of this stuff. I mean, each of these little pieces should take you maybe 1 to 2 minutes. And again, do the stuff you know how to do. Don't spend 30 minutes staring at a question you don't understand when you could be doing the rest of the test that maybe you do understand. And what starts to happen is, let's say you get to the first part. You're like, I have no idea how to do this part. And you go to the next one. And you're like, oh, okay, I can do this. As you do the things you remember, not only do you build your confidence to go back and do the other stuff later, but it actually sparks your memory for the stuff you don't understand. Because it kind of clears your brain to do the stuff you understand. Again, it makes you more confident, but it also kind of eases your brain a little bit, and it helps you remember the other rules. So my suggestion whenever you're taking a test like this is do what you know how to do first, and circle what you don't know how to do. You can always go back to it. And that's when you can really spend the time and relax and really think about, what do I have to accomplish here? Okay, so you don't have to do the test in order. Okay, I would recommend doing each question in order. So like, let's say question 20 has an A, B, and a C. Do A, B, and C if you can. But at the same time, you can skip around. You can do the things you know how to do. If you feel really good about something, focus on what you're good at. And again, it'll help your confidence, but it'll also kind of spark your memory for what you don't understand. So, or if you don't, even if you still don't understand, at least you have a better guess because you've kind of figured out other things on the test, and you can kind of use what you know there to apply it elsewhere. So, let's see. Anyway, so I think I'm about ready to wrap this up. I've lost a subscriber. They're like, no, this guy is just not. This is not cool. But anyway, I mean, again, it's not about the subscribers. This is my school channel attached to my email, so it's not all that fancy. Anyway, I think this is where we're gonna wrap it up. And again, tomorrow we're gonna do a review in class on some of the stuff we didn't talk about as much, and even today we did some of that. So, what about Fortnite? I've kind of gotten away from Fortnite. It's just not my type of game. I got to get a new graphics card for my computer too, if we're getting technical here. So, but anyway, I'm not going to get into all that right now. You can talk about that with me at school. But thank you guys for tuning in. Again, this really shows a step up in effort, and I can tell you guys want to do well if you're here. And again, if you're watching this, if you're not watching this live, that's okay too. It's good that you get on here and you watch this and you understand it, because a lot of people are going to have the same questions you have. And we'd still be going over the same kind of problems whether you were asking questions or not. So thank you guys for tuning in. Thank you guys for being reasonable in the comments section. I do appreciate that. It goes a long way, and it makes us more productive. And if we have any parents or other teachers tuning in, good to see you guys as well. So you guys have a good evening, and come see me tomorrow if you have questions. Good times.